positive, so I have 3/2 plus 1/2. And if you do in your calculator 3/2 plus 1/2, this will just give you 2. So this is 2 mv squared. That's my kinetic energy before. Now I need to find my kinetic energy after, which is going to be them stuck together. This is just for them. But I need to find that velocity first, so I'm going to use my momentum. 3 mv minus mv equals 4 mv2. 3 mv minus mv is 2 mv. Divide the 4 over, so this is half v. And you can just put this in your calculator. 1/2 times 4 times 1/2 squared is just 1/2. And then the m and the v squared are still there. And if I have 2 and I ended with 1/2 mv squared, then I lost the difference between them. So I always do final minus initial, but then people are like, man, that should be a negative. The change is negative, but I just asked how much was transformed. So the amount that was transformed is the 3/2. So I get a change of negative mv squared, but the change just means it was lost. Two skaters initially at rest next to each other on frictionless ice. A pushes on B. A has a greater mass, so A, B. They're initially at rest, which relates their momentum. So when they go off, they each transfer the exact same amount of momentum to each other, and they both start at rest, so they'll have to have the same momentum. I know they transferred the same amount of momentum because momentum is conserved. What A changes is what B changes, just in opposite directions, right? One positive, one negative. And then they started from rest, so their final is the same, just one positive, one negative. So we can cross off D and E. Now the kinetic energies, remember this one has more mass, but this guy is going to be faster, which is how they end up having the same momentum, right? B is a lot slower, or sorry, a lot less mass, but it will go faster. Now kinetic energy is 1/2 mv squared. Now mass and velocity both matter, but see how velocity gets squared? That means it's going to have more of an impact. So this one, even though it has more mass, it will be going slower, which is going to make it less than the less mass with the faster, because the faster matters more. So that's B that will be faster, so B has more kinetic energy. Is the momentum increasing or decreasing? So here, this is a force time graph, so the relationship is that the area of the force time graph is the change of momentum. Change of momentum being positive, right, would mean that P is increasing. So P is increasing, or momentum is increasing. By how much? Well, it's just the area. So this is a triangle, base times height over 2. That's how much it changed by. And a positive, which is why it's increasing. Shell is moving with a horizontal velocity v naught, breaks into 2 pieces. The larger has 3 times the mass of the smaller. The smaller has a velocity of -5 v naught. What is the velocity of the center of mass of the shell pieces? A lot of you probably are tempted to calculate this velocity right here, but I didn't ask for it. What I asked for is the velocity of the center of mass. That's complicated on this side, but it's really easy here because everybody's all together. The velocity of the center of mass at first was v naught. There was no external force, so it stays the same, so it's still v naught. Here, again, this is a position time graph, change in momentum. We're going to use the m delta v. Mass is 0.5. I need to do v final minus v initial. V initial is going up to over 2, so velocity of 1. In the second part, we're going down 3 in 1 second, so that's a velocity of -3. So then final minus initial is -3 minus 1. That's -4 times a mass of 0.5 is this change of -2, so B. Here, we're looking at a force time graph. We're looking for the change in speed. So I'm going to find the area. The area is the change in momentum, and then I can use change in momentum is m delta v. So first I need to get the area. I'm going to sketch, it looks like this is roughly, I'm going to say from 0 to 3, looks like a triangle with a height of about 200. So 200 times 3 over 2 gives me an area of positive 300. I don't know what I just did. Now this area, so a couple ways you can do it. Some people do from like 3 to 5 is a triangle like this, or you could maybe do like a rectangle from 4 to 5. If not, super, but roughly the same answer. So then this area, I have 2 times the 100 divided by 2, which is 100, but this is in the bottom. So this is a negative 100, and this area right here is positive 300. So then they make to a total area of 200. Mass of 30, divide the 30 over, that's like 6.67 for my change in velocity. This is a positive, so not a negative, and that's closest to 7. 1.5 is moving to the right at 5, and it sticks to a 0.25 that is initially at rest. What is the resulting speed after? They're stuck together. So this is 1.5 times 5, 0, and this is 1.75 v. This just becomes 7.5, yeah, 7.5, and then we divide over to get a velocity of 4.29 meters per second. 2 blocks of mass m and 2m move towards each other with a velocity of v. They collide and stick together. When they stick together, this one has more mass, so they'll be going this way and slower than v. I want to know about m. So m starts positive and then ends negative, but slower. So we can cross off these. That one. All of these start positive and end negative, but I want to end slower than before. So see how this one's going like 4 to negative 4? Not getting slower. This one's going from 4 to negative 1. That seems slower. This one's going from 1 to like negative 1, 2. I can't count. These are all 3s. You get the idea. This one's actually getting faster in the negative direction. I want it to be getting slower. C. Is there a net external force on the 2-cart system? So here I need to make a note. This is identical carts, meaning same mass. So if I'm looking and I'm saying, hey, this one loses a change in velocity of like negative 30, whereas the other one's change in velocity is only positive 15. Normally I would say, oh, well, this one must be like a heavier mass, right? Twice the mass that this guy is. But it says they have the same mass, so that means that the change in momentum for one is more than the change in momentum for the other. That must mean that the total momentum is not conserved. Well, momentum is only not conserved if I have an outside force, so we can cross off C. The P that is the greatest, the change in P that's greatest is the negative change, right? I'm losing, this is a positive change. So if I change more negative, I'm losing more than I gain. So overall, there must be a negative force. And the reason I know there must be an outside force is because the total momentum is not conserved. So that is because the total momentum of the system is decreasing. Just one guy's momentum decreasing actually happens in every single collision, and it doesn't mean there's an outside force. What is the velocity of the center of mass at t equals 6? So after, well, we know the velocity of center of mass is constant unless there's an outside force. We just said that there is going to be a negative outside force. So if a negative external force, it's not going to stay at v. If it was going at v and I have a negative force, see how that would slow it down? And I think I'm going to run out of time. Yep, I'm going to have to do the second half of the video later.